Welcome to the next session on recursion. So today we're going to the third problem, which can be solved using recursion approach. Till now, we have seen Fibonacci series, factorial of a number using recursive approach. Now we are going to see a problem, that is the third problem, which can be solved using a recursive approach. That is nothing but binomial coefficient. So what is binomial coefficient? So you know what is a binomial coefficient formula is? It's nothing but NCR. NCR is given by a numerator consists of n factorial divided by denominator have n minus r whole factorial into r factorial. So this is the formula to compute NCR. So binomial coefficient program, since the formula itself reveals that it contains factorial in it, since factorial of a number can be computed using recursive approach, even binomial coefficient can be computed using recursive approach. Since if you can see the numerator also contains factorial and denominator also contains factorial. And one of the important condition before finding out the binomial coefficient is you can find binomial coefficient only if n is greater than r. If n remains lesser than r, then it is not an invalid, it's an invalid input. So keep in your mind, since both the numerator and denominator consist of factorial of a number, and the factorial already we have seen can be solved by using recursive approach, we can solve this also using recursive approach. So coming to this particular problem, let us just solve this particular combination, that is 5C3, where n value is 5 and r value is 3. So this is what the first problem which we are going to solve. So look at this. The first variables which are declared for inputs are n and r. And then, as I said, it can compute binomial coefficient only if n is greater than r. So if in case n is greater than r, we are calling the printf statement, which prints you the result in the form of NCR is in the form of integer, okay, and %d, so it's a single value. And you can see that the formula is written here. So formula is nothing but, first we have to find out the numerator. Numerator is given by factorial of n. So we are calling a function. The name of the function is fact, and the parameter what you are passing is n. So in our case, n value is nothing but 5. So that means we have to solve first the numerator part. The numerator itself is nothing but fact of 5. So we are finding out what? We are not finding out the entire expression. We are finding out of this entire expression the numerator first. Okay. So this is the first function which we encounter. So as soon as this function is called, the value of n is copied to num. So now num is also equal to 5. Okay. So now let me write it down. So now num is equal to 5. So since it's num is equal to 5, so fact of 5 has been called. Okay. Since num is equal to 5, we have called fact of 5. So as you all know, factorial of a number we have already resolved. How do you divide this into a smaller instance? As we all know that to find out factorial of 5, to go into a general case, we need to subdivide this problem into a smaller instance, because we don't know directly the answer of factorial of 5, since it's a complicated case. So if you want to find out the factorial of 5, so since we need to find out the factorial of 5, as we all know, first we need to find out 5 into fact of 4. So this is a general case. So first it checks what is the current num value. Num value currently is 5. So it checks this if condition. Is it number is equal to 0 or number is equal to 1? No, both of them is wrong. If both of them is wrong, your OR operator will be a false. Okay. So if it is false, then it goes to else case. And in your else case, you can see that you have written return statement where you are dividing the problem into a subproblem where num into fact of num minus 1. That is nothing but this formula. So it's been reduced. So now since we are calling fact of 4 inside the same function, so you can see that fact of a num minus 1 is called inside same function. Now this parameter, that is fact of 4, now num becomes 4. Okay. Now once num becomes 4, the same expression, this particular expression is been solved into 4 into fact of 3. Okay, so if you can see here, when num value become 4, now num has changed from 5 to 4 because you have reduced here fact of 4. Now 4 is copied, the fact of 4 is copied to num, so now num becomes 4. Okay, so again it checks the condition. Is the num value is equal to 0? No, num value is 4. Is the num value is equal to 1? No, num value is equal to 1. Both the conditions are false. Okay, if both the conditions are false, again this entire expression becomes false, and then it goes to else case. In else case, what you do, you reduce that number. What is the current number? Current number is 4. 4 into fact of 3. Now what is the value of num? Now the value of num from 4, it has been changed to 3. So on it goes in this way. So it becomes 3 into fact of 2, because it's a recursive call. It keep on running until you reach the base case. Next it becomes 2 into fact of 1. So carefully observe. Now when you come across this subdivision, we are facing fact of 1. And now what is the value of num? Now the value of num is 1. If num value becomes 1, so what do you get? Look at this. Is it num is equal to 0? Wrong. It is false. If it is false, or if num is equal to 1, yes, it is true, because the num value is 1. Okay, so in your or expression, if any one of them become true, the whole expression becomes true. That is the way an or operator works. If it becomes true, it returns 1. What is the meaning of that? If it is a 0 factorial or 1 factorial, if you find found it, if you need to find, it is going to return the number as 1, because 0 factorial and 1 factorial as same answer, that is 1. So it's returning 1. So where does it returns 1 now? As soon as you see return statement, it goes to the recently called function, which was recently called fact of 1 was recently called. So now 2 into 2 is been written, 2 into 1 is been written, where to the previously called function, which was previously called fact of 2. So now this gets unfolded into 3 into 2. Okay, now 3 into 2 is a result of previously called function, which is previously called, that is factorial of 3. So this becomes 6. Okay, now this becomes 6. So 6 into 24 is an answer of factorial of 4. That is nothing but 24. Okay, so this becomes 24. 24 into 5 is an answer of, that is 120, is an answer of previously called function, which was previously called, so previously called function was fact of 5. So this is 120. So factorial of 5, where was it called? It was called in the numerator. So this numerator will be replaced by 120. Now once this is been installed, now it goes to the next expression, that is denominator. What is denominator? Fact of n minus r. What is fact of n minus r? So n is fact of 5, fact of 5 minus 3. Now what is fact of 5 minus 3? Fact of 2. So it has to find out fact of 2 now. So again, now since it's been called fact of 2, so fact of 2 means what is the current n value, the value you are passing 2 will be copied to num. Again, you know that this is not a straight up, we cannot solve it straight in the straight approach. We need to subdivide this into smaller instance. So that means if it has to be divided into smaller instance, it will never go to the base case at all, because num is not equal to 0. What is it equal to? It is equal to 2. Num is equal to 1? No, it is equal to 2. So both the conditions are false. So it never goes here. It goes to the else case. What happens in else case? It returns num. What is the current num? 2. So it returns 2 into, what is the function? Fact. Okay, fact of, what is the current value of num? Current value of num is it's 2, because you are passing 2 here. Okay, so 2, the current value of fact of 2 minus 1. What is 2 minus 1? Fact of 1. Okay, so now again 1 is copied as a value of num now, because you're calling this function with the parameter 1. So now num is 1. Okay, now 1, if condition it goes, is it equal to 0? No. Is it equal to 1? Yes, it is equal to 1. If condition becomes true, this condition, this expression turned out to be true, entire expression becomes true, because in OR, if any one of them is true, then entire expression becomes true. So what does it returns? It returns 1. Where? To the recently called function, which was recently called fact of 1. So it returns here 2 into 1. So 2 into 1 is what? 2. Where does this 2 goes? To the recently called function, which was recently called fact of 2. Where did you call fact of 2? Fact of 2 was called here because it was fact of 5 minus 3. So what is the answer of fact of 2? It is 2. So what did you get now? You have solved 120, which was numerator 120, and denominator, one of the aspect, you got 2. Now what you need to find out finally? Fact of r. What is fact of r? So it has solved till here. Fact of r value is what? R is equal to 3. So it has to solve fact of 3. So as I said, you already know what is the function. Now what is 3? 3 is the value of the parameter. So this 3 is copied to which parameter? Num. Okay, you're calling the function. So num value becomes now 3. Okay, so now we need to find out fact of 3. So you know that since it's a complicated case, we need to divide them into smaller instance. If we are to divide them into a smaller instance in recursion, we have to go to general case. So the condition will lead us to general case if it is a complicated case. Yes, we don't have a straightforward answer. So look at this. What is the num value now? Num value is 3. So it checks, is this condition is true? No, this condition becomes false. So where does it goes? It goes to else case. In else case, what? Num. What is the num value? Num value currently is 3. So what happens? So it becomes 3 into fact of, look at this statement. Look at this statement inside return statement. 3. Num value is 3. Fact of 3 minus 1. What is 3 minus 1? 2. So now it is calling a function with what parameter? 2. So again this 2 is copied to which variable now? Num. Now right now the num value is 2. So num value become 2. So again fact of 2 is not a kind of a problem which can be solved directly. We need to make it much more smaller. So again it goes to general case. So it's check if num is equal to 0 or num is equal to 1. It is false. Okay, so it goes to else. What does happen in else? It further subdivides. So this particular expression is further subdivided into 2 into fact of num minus 1. What is current num? 2. That is 2 minus 1 is 1. So now it is calling again the function with the parameter as 1. So now this 1 will be copied to which variable? It will be copied to num. So now num becomes 1. So you know from the previous experience, as soon as it reaches 0 or 1, it returns you the answer. So because it's a simple case. So now is it num value is equal to 0? No. Is it num value is equal to 1? Yes, num value is equal to 1. So if this is true, so what does it returns? 1. Where does it returns? To the previously called function, which was previously called fact of 1 was previously called. What is it returning into that place? 1. So this will be returned. So again 2 into 1 is going to be returned because you're saying in every general case you are saying return to the previous function. So 2 into 1 is going to be returned to the previous function, which is that fact of 2. So now you can see this will be replaced to fact of 2. So what is 3 into 2? That is 6. 6 will be returned to the previously called function, which was the previously called function. It was in denominator fact of 3. So in place of fact of 3, it will write 3 into 2. What is 3 into 2? 3 into 2 is nothing but 6. So it will be replaced here. So this expression 120 divided by 2 into 6. So what is 2 into 6? It's 12. Okay, 12. 120 divided by 12 is equal to 10. So what is 5C3 answer? 5C3 answer is 10. So this is how this particular problem is going to be computed. So I hope you understood this particular binomial coefficient problem. Since the numerator and denominator of the formula contains factorial approach, we can find out factorial through recursive functions. So indirectly, binomial coefficient can also be solved using recursive function. I hope so. You have understood this program. Thank you.